Okay, in 2.1 we're going to be talking about triangle classification, so we're just going to be talking about how we name different triangles. To classify triangles, we're going to name them by their sides and their angles. So if we're doing it all by sides, no sides are congruent, that's going to be called scalene. So none of the side lengths in it are congruent. So we're talking about the outside lengths of the triangle, not the inside angles. Okay, isosceles, that's ES at the end, has two congruent sides. It also has two congruent angles, and the way we figure out what angles are congruent, if you draw an arrow from the dash line to the angle that it sits opposite, those are going to be congruent. Okay, three congruent sides, it's equilateral, or we could say equiangular, because if we have three congruent sides, we're also going to have three congruent angles, and they're all going to be 60 degrees. And we'll find out why it's going to be 60 in the next lesson. Oops, equilateral. So three congruent sides, three congruent angles all the time. Okay, now if we classify by their angles, so now we're going to be talking about the inside of the triangle. So all acute angles is going to be an acute triangle. So that would be if it was like 30 and 70 and 80, all of them degrees, all of them are smaller than 90 degrees. An obtuse angle, we're going to call an obtuse triangle. So it'll have one angle that's bigger than 90 degrees and smaller than 180. And my last one, one right angle, so it's going to have that box in there to show that it's a 90 degrees, and we're going to call it a right triangle. Okay, classify each triangle by its angles and sides. So if I look at my angle, it's going to be a right angle, so it's going to be a right triangle. And I have two congruent sides, 5 and 5, so it's an isosceles. It doesn't matter what order you write them in, and then instead of saying triangle, if you just want to draw the triangle, I'm fine with that. So it's a right isosceles triangle, or you could say isosceles right triangle. Okay, my next one, none of the sides are the same, so it's going to be scalene by its sides, and then we have one obtuse angle, so it's going to be scalene obtuse triangle. Okay, so a median is a line segment joining a side with the midpoint of the opposing side. So if I have A, B, C, I'm going to pick an angle that it's coming from. It will tell you normally what angle you're coming from. So if I pick A is going to be my vertex. It says joining a, oops, this is supposed to say angle right here. Put angle in there. To the midpoint of the opposing side. So I'm going from an angle to its opposing side, and it should be the midpoint. Well, if it's the midpoint, that means the left side and right side should be congruent, so we need to mark it. So anytime I hear median, I always think middle, because it's going to sit in the middle of the other side. So it's going to, all of these are going to come off of an angle most likely and shoot off to their opposing side. There's going to be a couple of them that are going to be a little weird. Okay, an altitude is a line that extends from an angle, is perpendicular to its opposite side. So some of us were wondering what this meant, this upside down T. That upside down T actually means perpendicular, and it creates two different things. It creates two right angles in here. So when I'm talking about perpendicular, I need to create a right angle coming from that angle that I'm trying to be talking about. So we're going to come from A again, so we're going to come from here, and it needs to make a perpendicular line, and I show that it's perpendicular by putting that right angle in it, and it's going to the opposite side. The one that's going to be a little weird is if we are going from an obtuse angle, or obtuse triangle. Let's say we're coming from A here. There is no possible way to get to the opposite side and create a right angle. So what we need to do is extend my side to make that right angle in there. So that one, because there was no possible way to go to the opposite side inside the triangle to make it perpendicular, we had to draw it outside of it. Okay, perpendicular bisector, it's going to be perpendicular and bisect the other side. Bisect means is going to cut something in half. Okay, so this picture is a little weird because my perpendicular bisector is sitting outside of my triangle. If I draw a normal triangle here, and we're going to come from this, we'll say it's A, and we're going to hit side BC. So remember, when we label sides, we label them with 2 letters. So it needs to be perpendicular and make its midpoint. So let's say this sits in the middle. I show it sits in the middle. It also needs to be perpendicular. Okay, so it should look something like this. It's perpendicular and bisecting its opposite side and cutting it in half. Okay, my last one's the angle bisector, so it's bisecting an angle in half. So it's going to cut an angle in half into 2 smaller congruent angles. So we represent those by the little arcs. Okay, so we're going to draw some of them. So I don't have a ruler on here, so just work with me a little bit. We'll see if my line tool will work. So my first one is going to be median of AC. So I know it has to sit in the middle of AC. So let's try to get the middle here. Oh, that was bad. And then to show that it's in the middle, we need to show that the 2 sides are congruent. And then it's opening up to angle B because it has to go to the opposite side. So if I draw it to the opposite side, there's my median. So there's yellow. Okay, altitude using base BC. So an altitude was just a perpendicular line, and I know that I need to use my base BC. So my perpendicular line needs to go straight up. So this one, if it's going straight up, let's change my color. Okay, and then it needs to connect to A, so I'm just going to draw some dashed lines out here. So this is going to be my altitude, and to show that it's perpendicular, I need to put my perpendicular line in here. So we could go that way. We could also extend out this way and draw my perpendicular line out here. I would accept either of them because they're both perpendicular lines that are connected to BC. Okay, I'm going to erase these so I can fill in the rest. Okay, my next one, perpendicular bisector of AB. So I look at AB and it needs to sit in the middle. So I show it's in the middle, and it needs to be a perpendicular line. So this one is not going to connect to C, so it's going to be one of them that's kind of floating out here. And I show it's perpendicular. Okay, my last one, angle bisector of C, so it cuts angle C in half. So I show that they're 2 smaller congruent angles because C is being cut in half, and that's an angle bisector.